Hello, everyone, and welcome to another episode of Learning Rust doing Advent of Code, which, as you might know, at this point, we don't really have a proper title for this stream. But basically, what we do is we try to learn Rust. We meet every week, every Monday, and we try to solve Advent of Code exercises. And lately, we also started to compare our solution with some Python solutions. So it's also a little bit more interesting because we can see like different styles. We often see how Python is much more concise than Rust, but also how Rust forces you to really think carefully about possible errors and dealing all the possible exceptions that can happen. So today we are going to look at Advent of Code day 13 of 2021. So this is last year Advent of Code. And if you've never seen Advent of Code before, what basically is a coding challenge that happens every year during the Christmas time, so the 24 days before Christmas. This is the URL. It should appear on the screen in a second, hopefully.
It
Is it
did.
working? Yeah, it's working.
Yes.
So basically, what we do is you do challenges. There is like a storyline, and you have to progress through the storyline by solving a coding challenge every day. Nothing too fancy, but it's just a good way to exercise a little bit with Rust. And we have published all our solutions so far on GitHub, and this is the link. So this is totally open source. We are learning Rust. We are not experts. Most of the time we learn because people like you in the stream give us a bunch of good advice. So please, if you know something that we can do better, or if you see us doing any mistake, tell us, because we are here to learn. And also, if you have any questions, feel free to ask, because maybe we learned one thing or two that we can share. Now, without further ado, I'm gonna give it to Eugen. Or Eugen, do you want me to show today's exercise first?
Do we want to go through the last contribution that we got, maybe, before that?
Oh, yes, good point. So we had
Help out.
a very good contribution by Tommaso, who is one of most beloved followers of the stream. And what he did, he basically gave us bunch of suggestions on how we could have improved the solution that we did last time. So exercise number 12, if I can find it.
Yeah.
Just give me
Also,
a
share your
second.
screen, perhaps. I don't know if you're sharing it already.
Not yet. Let me load it first.
Fair enough.
Yeah, there you go. I found it.
Thank you to Tony Go.
Oh, Tony, thank you for following us. So let's see if I can share my screen. Okay. Sorry, we are now streaming with OBS, and there is a little bit more setup than before, so we are still getting used to it. Okay, now you should be able to see my screen. So basically, one of the problems that we had in our previous exercise, I don't know if you have seen it. If you don't remember it, basically, it was a graph problem where we needed to find a particular path. Actually, we needed to find all the possible paths respecting a certain number of rules in a graph. And we had a little bit of a problem because there was a little bit of duplication. Like some of the rules were around, every node was like a cave. So we were navigating through a cave system, and every cave could be either small or big. And there were rules based if the cave was small or big, you could do certain things or not. And we were doing a little bit of repetition in terms of checking whether the cave was big or small. We were doing that multiple times in different parts of the algorithm. So what Tommaso suggested us is to build our nodes as a struct. And like originally we were only using strings to identify the node name. But of course, if you use a proper struct, then you can put more information into it. And the idea was, okay, let's put is small or is end when you initialize the node itself. I don't know if we need to spend a lot of time going through this, but basically the idea was from a string, like we are doing here, you can build a node, and from the string we can infer all the different properties of the node, because if it's called end, it's an end node. If it's called start, it's a start node. And it's small only if every character of the name is lowercase. So basically, thanks to this contribution, we were able to simplify a little bit our code and avoid repetition. So thanks to Tommaso for suggesting that. I don't know if there is anything else worth mentioning there, but you can go through the PR if you're curious and check.
Just out of curiosity, this PR was cut after we already merged it with main.
Yes.
So there will be some Valgrind benchmark on top of this.
There is a benchmark, yes. I merged it already, but we can see the difference here in the conversation.
It's still in a comment in the pull request.
Yeah. So there is this 43%, which I believe is like 43% more code, right? More instructions.
More assembly instructions, so in theory it's lower.
Most likely this is justified by the fact that now we are allocating kind of larger structs for every node. But I don't know in terms of performance how much that degraded.
Not worked.
Yeah, it's not showing the diff, right?
303 millisecond against for part one. No, okay, it's not doing for some reason the differential. Okay, but well, in any case, it was just curious. Sorry.
Yeah, we could maybe spend some time later if we have extra time in running the benchmarks in the two commits and seeing the difference. But I like the style of this one, and I don't think it could have had a major impact in performance.
Tommaso saying in the chat it's slower.
Yeah.
If you remember the old numbers, Tommaso, we'll believe you.
No, but well, I was just curious. It's not just to say, "Oh, look, it's slower." It was just curiosity. Also, we can improve our GitHub actions and make them able to compare two arbitrary Git hashes. We can make a manual triggered action where you give one Git hash, another Git hash, and it will run the benchmark on both of them. Obviously, you need you need that both of the commits have the same part one, part two, part whatever. Otherwise, it's not working.
True. Yeah. Okay, so should we switch to today's one?
Yeah, sure.
Yep. Let's go to the README for the today's one.
Yep.
Should I present the README or somebody else wants to do it?
I can share it in a text editor, or if you wish to share it in GitHub, which might be nicer to look at, you can do that.
Let me show your screen then.
Cool.
And again, apologies if I'm very slow at doing this stuff.
And we'll do something entertaining in the meantime.
Yeah, exactly.
Do a weird dance. I don't know. Screen's visible. Okay, so this is my first time seeing this exercise as well, so you'll have to bear with me. So the story goes that we reach another volcanically active part of the cave. So it'd be nice to know which caves we can go into and which ones we cannot. We have a thermal camera, and we need a code found on page 1 of the manual. So the page 1 of the manual is a large sheet of transparent paper. It's marked with random dots and includes instructions on how to fold it up, which is our puzzle input. So presumably these are the dots that we have on a page, and these are like XY coordinates. And then it tells us how to fold it. Fold it along Y7 and fold it along X5. I'm going to assume this means move the points onto each other, either along the vertical or horizontal axis.
So yes, like you're folding a piece of paper, basically, in like horizontally and vertically folding it.
I'm going to read the explanation here, and it's saying the first section is a list of dots on the transparent paper. Cool, I got that right. Where 0, 0 represents the top left coordinate. Cool. The first value x increases to the right. The second value y increases downward. Okay, so it's literally, the top left point. Okie doke. The coordinates from this example are the following pattern. Okay, so they're actually showing us the points, the dots or points or whatever you want to call them that they gave us. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal, Y, or left for vertical, X. Okay, so the first fold instruction was a fold along Y, which means a horizontal fold, which designates the line formed by all of the positions where Y is 7. Okay, so essentially we're going to fold here, which I presume means we're putting the dots on top of each other, right?
Mm-hmm.
Fold the bottom
Yes.
half up. Some of the dots might end up overlapping, but the dots will never appear exactly on a fold line. I don't understand what this means, but we'll figure it out later.
Basically, if you say I'm gonna fold on, I don't know, Y7,
Mhm.
there shouldn't be any dot on the line 7 because you are like erasing it because it's kind of folded into itself.
Okay. Okay, I understand that. So was there something on line 7? No, in this case it was empty.
Yeah, otherwise you have to tell fold between line 7 and line 8 if you want to keep both of them, but then the input will become more complicated.
Okay, so they folded it here and they got presumably all the dots to overlap. Yeah, looks like it. Okay, now only 17 dots are visible. What?
Because some of them will overlap, so
Oh, yeah, okay.
you basically you might reduce the number of dots.
If you
Okay.
start with the 20 and 20, the one overlapping got counted only
Yeah,
once.
they get merged. Okay, I understand that. Fair enough. Because if the paper is transparent, the dot just below them remains visible, but it can be seen through the transparent paper. Okay, cool. Also notice that some of the dots can end up overlapping, which is just what we spoke about. Merge the dots together and they become a single dot. Perfect. The second fold is along x equals 5, so this is a vertical fold. Okay, and this makes, and I presume the goal is to figure out the number. The instructions made a square. The transparent paper is pretty big, so for now, focus on just completing the first fold. Okay, 17 dots that end up overlapping. Okay, how many dots are visible after completing just the first fold instruction on your transparent paper? Okay, and part 2, I'm just going to read it now since we're here.
And it's very small. Yeah.
It's finished folding the transparent paper according to the instructions, and the manual says the code is always 8 capital letters. What code do you use to activate the infrared thermal imaging camera system? Okay, so
By the way, it took me a while to understand the last exercise at the time, because generally when you do this advent of code things, you have a very clear output and it's generally a number. In this one, you literally have like a piece of ASCII art, and that ASCII art contains letters, and it took me forever to understand that just because it's a one-off type of exercise. So this might be interesting to see later on.
I'm curious how we're figuring out which character it is, to be honest. Yeah, we'll see.
I will show you in a moment if we go to Python implementation.
Cool. Do you want to do the Python one first, or should I go through what we have in Rust first?
Normally we do Python first.
Cool. So let's switch the screens over to Roberto's.
Yes, let me direct that.
Thank you, Mr. Director, sir.
Right. There you go, Roberto.
Okay. Okay, there is a lot of input. Okay, I'm scrolling down the inputs. Part 1. Part 1 is a couple of utility, map an iterable to integer, map a list of iterable to integers. Cool. Part 1, it takes, I already parsed the input in input, that is the list of points in the tuple of numbers, and folds, that is the folding instructions. Part 1 is just taking the first fold. So I take the first fold, that is, take all the fold, split by line, take the first one, split by spaces, take the last piece of it. That in our case will be, let me scroll a little bit. This along this piece will be x equal whatever. Then splitting on the equal, I get x or y, because it can be x or y, and a value. Then I convert the value to integer because after a split, I have a string.
Mm-hmm.
I initialize a empty set. This set is the set, of coordinates, so tuples of two numbers of my papers, of my transparent paper. So for all the x and y in mapint of our input, splitted by line, splitted by comma. So with this line, I'm taking all the lines, then I split them by comma. But at that point in Python, you have two strings. And then I want to map them to integers with this trick. I use two of them because it's not a list of numbers, and you can use a mapint to if it was a list of numbers, but this is a bidimensional structure. Is a list of lists of numbers, because even if they are always two, for Python is a list. Then if is x, I go with x. If is y, I go for y. The code is exactly the same, changing x for y and y for x. Here, due to the fact that I only have to do one fold, I don't care about storing the first state, that is the state after the parsing. So I say, if I split by x, that is the case, the new x is 2 times the value of the split, or where you have to split, minus x, because basically is a mirror. If you split on 7 and the number is 8, you need a 6, because it will go in column 6. If you split on 7 and you have a 10, you want 4. So with this split, with this mathematical stuff, add it to the grid.
I think we have a small diagram in the Rust part, so we will review this concept later as well.
If this grid, I add this point to the grid. If the point is added twice, it's only added in the end, will be there once, because this is a set, it's not a list. Then I return the length of this set, that is our 716. That is, I think, the output that was written in the README. Part 1.
Yeah, that was.
Let's do also part 2, so we can jump to the Rust later, because part 2 is very similar.
Well, I'm curious about the parsing of letters, so yes, do show.
I just show the letters. I parse them with my eyes.
Okay.
Grid is at this point is the set of what we made before. So this is all the parsing to get the first grid. Make me a set, mapping the input, splitting, mapping everything to int. So the output of this will be a set of tuples of integers, always two integers. Now, for all the fold that I have to do, I split again, x or y and value. I take value as an integer. Then, for all the point in the grid that I have, if it's x, I add the reflected point and I remove the old one. So, becoming smaller and smaller. If it's y, I do the same, but in y. And I return the grid after I did all the folds. Then there is this function that is display, given a grid that is a set of numbers. I take the maximum x, the maximum y. I allocate an empty list of spaces. Then I go through my grid and I put in the coordinates that comes from the grid a full block that is a UTF-8 charter. And I print it. My output is this one of part 2. That is RPCKFBLR. Here your question, Eugen, is how you did the OCR of this? I didn't. I read it and I wrote it in Advent of Code, and I clicked submit and it was right. So
fair enough.
On top of this, I also did the graphical representation of all of this, as we can see here. This one. This is the wool grid at the first iteration. Then we fold stuff, and when we arrive at the end, this was for another input that was mine, not Luciano one's. So mine was JR Z, B, L, G, K, H. This was my input, not Luciano once.
Mhm.
And so here we have the same. Obviously, it's more readable if we print this like this, but still is readable even if we just plot the position of the points.
Mm-hmm.
And at every step, the space become less and less.
Mm-hmm.
Nice. I like this visualization.
Yeah, it's cool.
Done. So, do we want to jump to the Rust one?
Sure.
Yes.
Let's
Let
do
me
that.
transition again.
Yeah, let me know.
You are on, Eugen?
I am on. Okay, so no need for the README anymore. I'll just go straight into our code and have a look at what's been done here. So we have a struct for a point, which makes sense. It was the obvious first step. We're implementing from string for it, which is fair. We're just splitting. This is all pretty simple standard stuff. Ask me in the chat if you want me to go through this. But we've been doing this quite a lot over the last streams. We had a lot of challenges which involved points. So what are we doing with the point? We're implementing a fold X and a fold Y. And
By the way, if you look at that comment before fold X, this is what I mentioned before, that we have a little ASCII diagram.
Yeah.
Showing
okay, so
you
this would be...
Yeah.
Go ahead, Luciano. Sorry, I interrupted
Yeah,
you.
so basically you can see that hashtag is a point. The pipe is like the point where we are folding. And basically, if you look at the end, line 26, you can see that what's the projection over that folding line. And I think visualizing that this way justifies a little bit more why the formula works.
Yeah. Essentially, it's saying it moved from the point of star to the point of hash,
Exactly.
where originally it was just hash.
Yeah, my formula was 2 times the splitting position minus the coordinate. Yours is slightly different, but I think mathematically it's the same.
Yeah, it's
because
just
you're saying the splitting minus the distance after the splitting by 2.
It's so what was yours? Let me just write it underneath.
Mine was just 2 times the split positions.
So
2 by px. No, what is the splitting? No, it's x.
I think
the
it's
splitting
x
is
actually.
X.
2
Okay,
times
so 2
x.
times x minus px.
Okay.
Yeah, if you do the multiplication and then you sum, it should be the same.
Should be the same, yeah.
Yeah.
Okay, cool. Sorry, I'm not going to modify the...
Actually, I'm curious later if your formula is faster, because I think you are doing less operations.
Might be.
But they're still just math integer operation, I think.
Yeah, it should be super fast, and we are not doing millions of them, so it shouldn't be noticeable.
It's minimal. So interestingly, we're doing the fold on the point itself. We don't have a grid that does the calculations. Each point will fold itself. I'm curious what happens when we return false and why we do this. I'm assuming this is because it goes over the edge and we don't count it anymore.
Let me remember this. So basically what we say is...
If the point is before the reflection point, if the point is to the left of the reflection point, we don't care. We are not reflecting it.
I'm presuming it's about cases like this where we're folding at a point like this, for instance. But
no, I think it's when your point is on the left of the pipe.
Oh yeah, you're right.
The point stay on the left of the pipe.
And you don't fold it. Okay, fair enough. I understand now.
Yeah.
Okay,
if
so
the point is on the left of the pipe, it stays there.
Okay. Got it. Cool. Okay, and we're doing the same for the y, and we're mutating the value here on the point itself. Cool, and there's a function called fold, which figures out if it's on x or on y. Okay, cool.
Yeah, we do that through that enum that you see below, line 53. which is effectively which direction do you want to fold. So the two variants are X and Y.
Yep, which is the column or row number, and then you specify it's a row or a column. Okay, cool. Which is also implemented as a from string. Oh yeah, and with a fold along in the text. Again, this doesn't seem to be anything too fancy. And for part 1, we split it on the new lines because the input itself, I think,
I think there is one interesting thing we can discuss here in line 64. Just to underline a small difference with Python. As far as I understood from Roberto implementation, and correct me if I'm wrong, when in Python you take a string and you do split over at the limiter, if on the left side you have like multiple values, the split will already apply the two parts into the values, right?
Yeah, it's doing the composition of the
It doesn't give
assignment.
It gives you an iterator, but it does the decomposition as well, or it doesn't give you an iterator at all when you use split?
I think split give you a list of strings.
Okay, so split is kind of eager. It will split everything by default, right?
Yeah, I think so.
Okay, in Rust, if you just use split, you basically get an iterator. So it will be on us to keep iterating 2 times and take the different parts. But most of the time you want to split only one place and take the 2 parts. So split once is kind of a helper function that will do pretty much the same thing we did in Python. So we have been using this a few times.
In Python, you use a split. If you put 2 variables on the left and you split more than 2 elements, you're getting an error, a runtime error. But basically, it's like Python is. You have to, if you want, you have to do a try except around it if you want to catch the exception, or you are sure that your input is fine, or you are fine giving an exception to the final user.
Okay. Yeah, it's interesting as a difference highlighting thing. All right, so let's go over what part 1 does. It also does the split once trick, which is essentially separating the folds from the actual points list or points lines.
Yeah, this is something interesting because Roberto did a little bit of a hack there. You already split your input in 2.
Yeah.
Here we are effectively doing the same, like taking the full text, finding the line break, and taking the 2 parts as grid definition and split instructions. Sorry, fold instructions.
Fold instructions, yeah. Yeah, so we're splitting it by line, parsing it using the thing we implemented above to parse it into a point, and we collect them all into a vector of points, which makes perfect sense.
Again, here, instead of this map, could we have used the filter map passing only line, column, column, parse?
Which line is this one?
78. Because you are applying line parse, so you are applying line parse to all the lines.
Yeah.
Was possible to apply line is of type what?
Essentially, I think this is what he's.
The problem here is managing errors, because here we are just unwrapping. So if there is an error, we will panic, basically. So what we could have done, and I think we did it in some other exercise, we could have used filter map and then convert an error into a none. Because in filter map, you need to return an option. So you can convert an error into an option. And that way, the semantic is a little bit different, because in that case, we are saying if there is an error, just ignore that line. Here is literally if there is an error, panic.
Okay. The difference is that one. Cool.
Fair enough. Okay, and then we have, because this is part 1, which is a single fold, we're taking the first line from the iterator, we're unwrapping, parsing it, unwrapping again. This is beautiful. And then we're going through each of the points, folding them based on the first fold, and we're collecting them into a hash set of unique points. Okay, so we're getting rid of any points that overlap in this way, and we're getting each unique point, and we're returning the length, which I'm assuming, since we have tests, it works.
Yeah, another quick thing about
Okay. So you are keeping all the points. You're not discarding them. Just they will overlap. Okay.
mhm, exactly, yeah. And the hash set will basically
Yeah, discard them for us. That
exactly.
makes sense.
Can't you return points dot into iter dot count, something like that, to avoid the collection? Or you need it? Base a set.
I think you need to collect
You
them to
need
count,
it
because
for.
otherwise it's an iterator, right? It doesn't know how long it is.
Okay.
Yes, I think so.
Oh,
Not sure I'm
actually,
getting
no.
your question, Roberto.
No, he's right, because points is already a vector. It has a defined, it's not an iterator. The
Oh yeah,
moment
I
you do
think.
iterator, you might just be able to do points count.
No, but you
Mhm.
have to convert it to a set. You're right. You have to convert
Oh,
them to a
yeah.
set somehow.
Yeah,
Yeah,
so it
you
needs
need.
to be collected.
Yeah.
Well, we could have kept it as a set from the get-go, and then I suppose, as in instead of storing the points as a vector, we could have stored them as a hash set from the start, and then every time one of them folds, I suppose the hash set
Yeah,
would just
but you
drop
have to
it.
be able to add and remove from the set. In this way, like I said, it's never removing the points. They will just casually overlap.
Yeah,
Mhm.
exactly.
And because every point here is basically mutating itself, that's
Hmm.
why I think this implementation was convenient.
Yeah,
It's
no, it
like,
makes
okay,
sense.
let them mutate and then at the end collect whatever is
It
there.
it sounds less nice to have done this with a hash set, as in it sounds more error prone to me at least, and harder to wrap your brain around. So this makes perfect sense. And let's see part two, I suppose, because I didn't see any questions in the chat about this so far.
Do you
So
want to run the test for part one,
that's
maybe?
actually a good idea. Test folds, test example, test part one. Let's see.
Yay.
Yay! It passed.
Like if we didn't try it before
Yeah,
yesterday.
exactly. As if I didn't make any changes to this code. Cool. All right, so part two will obviously do pretty much the same thing with splitting the input, parsing it into a vector of points,
Mhm.
then doing the same for the folds. We're getting each line, we're parsing it, we're unwrapping it, and then we're going over each of the folds, and we're calling fold for as long as we need to fold for each of the points.
So
Okay.
for each of the point, for each of the folder, you call fold. So
Yeah.
after a bunch of folds, you will always have the same complexity for every loop
Yeah.
because you are not discarding points that overlap. You are
Mhm.
keeping all of them
Yep.
until line 106, where you create the set from that.
Yeah,
Yeah.
exactly. So
Okay.
we might optimize this a little bit if we want to.
Yeah, my solution instead at every loop, I discard the one that got reflected and I add
Mm-hmm.
them. Then, being already a set, if there was something already there, they just stay there,
Mm-hmm.
and otherwise they got added.
I
Mhm.
So
wonder
I
which
don't
is
need
quicker.
this. Python, not for sure.
No. In
But I
terms
mean,
of the two
implementing the
implementations.
logic in Rust, I don't know.
Yeah, I suppose the logical difference here is that I am applying all the folds for every single point.
Mm-hmm.
So I basically, um,
Yeah, but
Your
yeah,
complexity is always the same at every fold.
yeah,
mhm,
With the Python approach, the complexity slice in half or less at every fold, because
exactly. Yeah,
every fold you have less points to fold.
not
At every
yeah,
fold you
necessarily.
have less.
It depends if any of them overlap, because if none of them
Yeah,
overlap,
okay.
you have the same, right?
Statistically you have in the end we know
Yeah.
how many we have, and they are not the same amount as the
No,
start.
you're right. There should be less. Yeah, but then you do need to reallocate them, right, into the hash set.
yeah. I suppose here we are avoiding the reallocation in the asset.
Yeah. So I'd be curious what the difference in terms of actual microseconds is.
We can try later
We'll try.
to
Yeah, let's go through
change
the
this.
code, run it, and see how everything goes, and then we can change it and see how it behaves. All right.
Mhm.
So we're getting a brand new unique points list, And uncomment the following code to print all the points.
Yeah, this was a little bit weird because I actually changed the test a little bit because I suppose what I could have done was to match on this particular string, like the ASCII art as a string, and make sure it's the same. That could have been another way to do the test, but I did change the test to only check the length. So this is a little bit of a hack I came up with.
I thought you implemented like a character reader.
OCR.
Yeah.
No.
It's like there are 4 wide I see. So it was like, right, this is a B, this is an R, this is a P, that kind of thing.
All we can do that is not that difficult with fixed characters. It's just a lot of code.
Yeah, I presume. It depends. Yeah. Well, to be honest, you can even hard code them. I presume it's easy enough because you just split every 4 on every row.
Yeah, but
Then you can match.
you need a dictionary to look up for
All the
shape
letters.
references.
Yeah, exactly. We need to like hard code the references and that's it, which is the brute force approach of just like do it. Interesting. And the test is then just checking the length now, right? Yeah,
exactly.
Okay.
So the test is a little bit hacky. It's not necessarily like it's not doing the same thing that Advent of Code is actually testing for.
Oh, but you could return a string and assert on the ASCII art. It's not.
Yeah, but you need something to parse the thing and so on and so forth. So yeah, it's a bit tricky.
No, on the ASCII art, not on the characters.
Yeah, you could return the ASCII art as a string itself,
okay.
and then in the test assert that it is the same as you expect.
Okay, that the strings are the same. Yeah, so render it out essentially.
Yeah.
Nice. Okay, cool. That's fair enough. Okay, so that's this. I don't know if I ran the test. I mean, we already said it's a bit hacky, so I should probably run sorry, actually, do we want to try to see if there's a difference between vector and hash set?
So we have a question first. So related to the PR, before more instruction doesn't mean much slower, right? Oh, this is
more
the PR from Thomas.
More instruction with Valgrind means that he prefetched for level 1 cache more assembly instructions. That in theory is slower, yes, but depends obviously on the instruction, so they can't be related to exact time. Also because if they are instructions that call the kernel to get a memory allocation, they will be obviously super slow instruction. If they are instructions that are just grinding numbers, they stay inside the core and they don't go outside. They are more but faster. To be honest, I would prefer to implement a GitHub action that does the comparing manually and run it again because that was a branch, then we merged the branch, then you open it against main. I don't remember if it was already merged or not. It can have done some stuff in a bad way to test that, but yes. Also, I can't test it locally because I'm using WSL under Windows, so there is not Valgrind, and you can't do that on OS X2 because I think Valgrind is not working there for some reason.
No.
And basically, we have to use the Ubuntu GitHub action. That, by the way, some times ago it got broken because we are using Ubuntu latest, and in Ubuntu latest, Valgrind was not in the apt package management system. So for some days it was not working, but then it started again because they added.
Apparently, they re-added it at some point, so probably somebody complained.
Yeah, popular demand.
Exactly. Fair enough.
So what we could do is running cargo bench in this folder. So go in the folder for exercise 13 of this year.
21, exercise 13, cargo bench.
Remembering that running this on a laptop adds a lot of noise.
A laptop that's doing 50,000 things because the fan is spinning. Yeah.
Yeah, including streaming. So
yeah. Yeah, there's a bunch of stuff.
You can only see if it becomes crazy fast or crazy slower.
Not going to be accurate. We could try to do something on either like Maybe containers, because we could limit their resources, or we could run them on the cloud somewhere.
If you really want to run them on the cloud, you could merge now the pull request to master, to main.
And it'll run it on the
Then
GitHub action,
doing
yeah.
the hash set change as a new pull request.
Let's do it
At
locally
that
for
point,
now.
all the GitHub action automation will trigger when there is a new pull request against main, and they will compute numbers for you.
Yeah, but then we don't know if the runners are the same kind of specs every time.
Valgrind is telling you number of instructions, so
yeah, that's true. Yeah, but
the good part of Valgrind is there is not a lot of, there is
Yeah.
a little bit of noise, but not a lot.
But as you said before, the instructions themselves could be more or quicker or more and slower at the same time, depending on what instructions we have.
In theory, if they are more, it's slower.
Yeah. Okay, let's try it. Well, for now, this one has, 114 microseconds for part 1 and 160 for part 2.
So that's the one we care about, 160, right?
Yeah.
Yeah, so the fold is not the biggest problem. Probably the parsing is the most time-consuming activity here.
It's either, it's probably the parsing.
the two part have the same parsing.
Yeah.
Right.
Right.
So
no, the second part. Go ahead, Luciano. Sorry.
The first part stops at the first fold instruction.
Okay.
But to be fair, I expect the majority of the work is in parsing all the numbers at the beginning, all the points at the beginning.
So the parsing of the points is the time-consuming part here.
Yeah. If we look here, this one. Oh no, part 1 is also going through all. Oh no, it's getting the lines and then it's getting just the first.
Yeah, but the folds are 10 folds. The points are
hundreds.
Yeah, so the points parsing is the most expensive operation here. So presumably we're not going to gain much of anything with this change.
Let's try to
implement let's do it. Okay, so the idea would be to make this a hash set, right? So that
let's see how to do that.
I'm not sure if it's going to complain when it mutates. Point.
You cannot mutably iterate over an hash set, I think.
So this means I need to reallocate,
exactly.
Right?
We can mutate the hash set or not while we iterate over it?
I think we can map and allocate to a new hash set.
But at this point it will be slower.
Yeah.
Sure.
You are reallocating 8 times, and every time it could be a smaller set.
Yeah, I was just thinking that we did before to go through a set and add and remove stuff from the set, or not?
So essentially, points is going to be equal this. Do we have for each or something? No.
So Tommaso is asking, the fold method can take the ownership of fold variable. This is a question. Could this improve the performance? The fold method can take the ownership of the fold variable.
It cannot, because the fold variable, the fold method.
The fold must be done on multiple points.
Yep.
The fold must be run on multiple points, so every point needs a reference to the to the fold instruction, and it can't consume it.
Yep.
Can we replicate the same thing you did in Python, though?
If we want, why not?
Because I mean, here the design choice was to make every point mutable.
Okay, so
do
we need to do that? I don't think we.
No, we can keep the point immutable, but the hash set of point mutable.
Well, the hash set. Okay. So anyway, this needs to become a hash set.
You remove the old point and you reinsert the new point, right?
Yeah.
I insert the new point and I remove the old one. Yeah, at every.
Essentially, we have to reassign the points here, right? So points is going to be.
Let's do one quick thing. Let's do you know where we have the fold instruction in the point
Yeah.
definition? We can do fold new, like a new
Okay.
function that doesn't mutate itself but returns a cloned version.
And then we can go through it. Okay, sure, we can do that.
So we can implement the same thing we do in Python. We have only one set. Every time we remove a point and we add the folded version of the same
Okay, so this will just return matrix.
No, let's do a new function so we don't break part one for now.
That's fair enough, actually. Fold and return.
Yeah.
Fold new was the suggestion of Luciano. Makes sense because he's creating a new.
Yeah, okay, sure. We can do that. We can have the same logic inside.
Exactly. You just need to clone itself first.
Yep. So mute self and the fold. We need both these things. And instead of returning a bool, it's going to return a self, essentially, right? Or do I need to give it a type?
No, self with uppercase S.
Cool.
And you can also take a self that is not mutable. So the first argument.
Oh yeah, I don't need it anymore. You're right.
Perfect. Just ampersand.
Just a reference. Okay. So now we need to.
Now what I will do is probably self.clone and then fold X.
Yeah, but.
Or you can just clone before, yeah.
New thing. I'll self clone.
Actually,
Rust wants the snake case.
Yes, and also you need to mark this one as mute. Let mute.
Yes, you are correct. Yep, and then we go new self, right?
And I think that should do it. Let's
We need to also
return but
full
dex is returning a boolean now. Full dex is returning a boolean now.
Is it? Ah, frick.
Oh yeah. Okay, no, wait. Go down. So there you are mutating. Okay, put. I think that.
Why is it unhappy?
I think you should.
Because you need a semicolon on line 57.
57, yeah, and then you can just say new self without even the return.
Even
You're right.
remove the return.
Correct. Okay, this should work with the cloning. Okay, so we will need to call fold new. So for points iter into iter, I think is what we want, right? Map, I guess.
Yes, let's see.
Point.
I can never remember all the. Meanwhile, Tommaso is asking, should implement copy, but it will be more expensive. I'm not really sure I understand this comment. Can you explain what do you mean by more expensive?
Also, who should implement?
No, I think it was meaning the point struct should be copy rather than clone. But I'm not really sure why that will make it more expensive. But yeah,
yeah.
It is referred to the previous fold points.
The previous fold point.
So hang on, let's go back up there with the code. So this reference to self and the reference to fold. And new self is a clone.
No, I think he's referring again to the ownership of fold to the point that we are passing for the solution with the fold in line 45.
Okay, this one, the old one. Okay,
yeah,
okay.
Because we said we can give the ownership of fold to the point because fold is needed by all the point. Yes, but we can give a copy of the fold to all the points and they can have ownership of the copy of fold. But at the point we are copying fold 700 times.
Yeah.
I think was referring to this. Tell me, Tommaso, if I got it right.
Yeah, and I think that makes sense because the difference between clone and copy, they are almost the same in practice, but copy is implicit. So basically, every time you use that variable, it will create a copy. you don't need to use references.
You
just
don't need to
copy itself.
explicitly clone it. Okay.
And that's the case, for instance, in the standard library for most integer types, because they will be as big as a reference, so you can just copy them all the time. And with clone is like you can copy them, but you need to explicitly say when you want to get a copy by calling .clone.
Oh, here
So
you have
this
to
one,
pass fold to the fold new, otherwise we are folding new on nothing.
yeah.
Pass a parameter to that poor function.
To put the fold, right? You are, and it has to be a reference.
Mhm.
Okay, this in theory should be it, right?
Run the test because the number of points must match the 97.
Correct. Thank
So we
God
know
we
if
have
this is
tests.
right running this.
Yes.
Correct is correct.
Wonderful.
Run now the cargo bench, but I don't think we'll see a lot of
So,
difference.
just for reference, it was 160.86 microseconds. We'll see what difference this makes, and then we can pass a clone of the fold to the numbers.
We can also see if we can keep also part one as a noise reduction method, because part one is not changed at all from previous run. If it changed a lot from the previous run, it means that we have noise. Okay, for example, part one is faster because noise. And part two is?
Give it some time. 143% slower.
I think it's slower.
Okay, so it was better to mutate.
It was better before.
Should I undo the changes then?
Why do you think is that? Is it because it's doing a lot more allocations anyway?
I think because the collect is giving you a new hash set every time.
Yep.
Oh yeah,
We are not. We are in Python. We are not creating a new hash set. In Python, we are using the same hash set,
but we can reuse the same
stuff.
hash
Do
set
I
here
need
as
to
well, right?
collect?
Here you are no well that line is just count the stuff because you don't have to convert an hash set to an hash set. Because,
I guess no, it's not happy if I don't collect it.
No. I mean line 113.
Ah, this one.
That line is not very very smart now.
No,
Because
you're
we
right.
already have an hash set. We go into iter, then we go back to an hash set, and in the end, yes, we have to return points length.
That should be it, but I really don't think this is
No,
going to make much difference.
it's not that the problem. No, I was not.
I'm running the bench again, but it's so I think allocation is actually more expensive than mutating.
Yeah, but
I'm wondering if we can use that drain method.
Now is not nightly anymore.
There is something we can use to basically, while we iterate over the items in the set, remove the current item and add a new one without breaking the iteration, because that's what you're doing in Python, or not?
Yeah, in Python I'm not getting a new hash set. I'm keeping the same set and just adding and removing stuff because I can. The problem with Rust is probably that you are iterating on something that you are changing, and Rust is not super happy about it.
It's 3% better than
that. No, it's 3. Don't look at that. That is against the previous run. Yes, it's slightly faster, but
so I'll make it back into what it was originally, because like if we're committing, I'd rather not commit something which is worse, if that makes sense. Or we can play with using the same hash set using that drain that Luciano mentioned.
Yeah, I need to check the documentation,
but I'm not familiar with
see
it. Yeah.
if there is a way to basically map a set without reallocating a new one.
Let's see what it says. Thanks.
I don't know if anyone in the chat knows.
Clears the set, returning all elements in an iterator. I mean, supposedly, but then there is something we can do.
There was not
So instead of map, can I do a for each? And then I can do a fold new and I can push it into points itself.
So I don't think it was drain, to be honest. It was something like keep if.
So we can use .drain, which clears the set, returning all the elements as an iterator.
How was it called? Insert or add or? What was the name for adding something into a set? Insert. I'm guessing this mismatch. What?
So what happens if you say drain?
I'm draining it, which gives me an iterator, and then I'm going over each of these elements, and I'm inserting the new value, right, into points after it's been drained.
There?
So this is saying that, sorry, it expected a tuple, I guess, but it found a Boolean.
Fold new, is it returning a Boolean?
I don't think so.
No, it's returning itself. But insert
should be returning a self, yeah.
Are we sure?
I'm not sure if it was insert. Maybe it's add. No, I don't think add exists. No,
oh, is the for each that is returning a Boolean. The whole points dot insert.
Okay.
So if you put the curly braces and a semicolon in the
because it must return nothing.
But now it's unhappy.
Now there is another problem. Let's see what's that problem.
Come on. Tell me. No, that's not this. This is it. It's not telling me.
Okay, go with a cargo build from the console. It will tell you.
If you click at the bottom in the blue bar where you see the
wait,
error
cannot borrow points. Sorry.
Google is alive.
Google was, yeah. Okay, so cannot borrow points as mutable more than once at a time. Oh, because I'm mutating it when I'm inserting, I suppose.
Yeah, okay, because when you drain, you get an iterator, which is probably borrowing the
values,
original set in a non-mutable way.
Yeah.
Which is a good way to protect you from iterating and mutating at the same time.
Okay, can you do drain dot collect and turbofish a vector of points?
But I can probably just collect and for each directly. No, I can't.
Yeah, but you don't know what to collect. You have to turbofish the type into the collect.
But then you are still reallocating, right? So it's the same implementation.
Yeah, but let's see.
How did you turbofish? Because we haven't done this in a thousand
just
years.
Just declare on the left side, let points, whatever.
Without let.
No. You can turbofish on the collect.
You can, I think, but I prefer to do it this way. It's just easier for me.
Like this, basically?
No.
You can just do a vec.
We are copying.
One at a time, please. I can do a what?
You could do a vec, like doesn't need to be an hash set.
Oh, okay. Points drain collect.
I mean,
type annotations needed.
Semicolon after the collect on a new line p dot for each.
But we are reallocating. The method for each exists.
And you need to do that.
Well, I can do for p and
p dot iter dot for each.
Yeah, or for p and points. Don't think this is going to be any quicker.
No, but let's try.
This one. Jeez, I really don't like this thing here. Cargo bench.
We were around 160 with the first solution. Now we are 370. Okay, let's see where we go now.
Let's give it a sec.
Part 1 must still be around 100 microseconds. Okay, 1 and 9.
That's fine.
100. Yeah, this number will make sense.
We got any more comments? Is anyone wondering what the heck it is we're doing here and why?
Please, if you know what we are doing, tell us.
Yeah, exactly. It's just as bad.
No, just as bad. Okay.
So essentially, the original was better.
The never changing the size of points was faster.
Mm-hmm.
Okay.
I think just because the size is not going to change that much.
Yeah, the size is constant, so no memory allocation.
Yeah. And that way we kept the same things allocated. We allocate them once and they only change their own values. So
Yeah,
Yeah.
until the very last moment when you do the hash set to count them, and even there you collect an hash set because you want, because you're lazy.
I'm gonna
Because
reset it.
otherwise you could just uh, count the unicity of that. No, but well, like, the hash set probably is the fastest way to count the unique points, because sorting them and counting them would be slower.
Much. I'm gonna reset to what it was originally.
Yeah, okay, okay.
I mean, it was a fun exercise, but it's not better in any way.
Cargo bench again, just because.
Yep, we can do one last thing, which is try what Tommaso was suggesting. Instead of passing a reference to the fold, we can pass a clone of the fold.
Copy.
Oh, copy, sorry, yeah.
We have to implement the copy trait and pass fold without the reference, right? Was the
Do
suggestion.
we need to? Did I type? Oh yeah, I typed an S there. Sorry. It's. Oh yeah, because it's ours. Fold is our struct. Yeah, fair enough.
Fold is our structure, so we have to implement the trait
Mm-hmm.
or not. Or you can derive it.
There you go. 136 microseconds.
Yeah.
It's back to normal.
Yeah. Okay.
Okie doke.
I have to try the same with Python to see if it's faster.
Yeah, that would actually be cool. Right. So where is our enum fold?
Yeah, I guess in
Right.
Python is a little bit more opaque when it's allocating, right?
So
Like
we're
you need
No,
to
but
know them.
but you know when it does that. No, but you can't derive copy as
Can
you
you?
derive the bug.
I think so. I think you can do
Mm,
that. I think you need to do
yeah,
both.
clone and copy. It was
Wait.
yeah.
Not in that fold.
Not in this fold.
This
No,
is
that
the
is distraction.
enum. This is
Oh,
just if
crap.
you're folding on X and Y in the point.
I'm sorry. Right.
It's the full distraction that we want to copy, no?
Yeah.
But
So if you just change, wait, what's the
that was
difference?
it. Fold is just an enum. That's it.
Why do you want to make that copy? I mean,
So
what's the advantage?
it's
Was this Tommaso's suggestion, to be
exactly.
honest.
It was more
I don't
just
know
to
what
try
is the
it.
advantage.
It's more to try it and see if it does anything.
But he was saying fold points. I understood that he was referring to the points themselves.
Okay, so I got lost, sorry.
But maybe I got lost.
Okay. So okay, so we're not
You
doing
are
anything.
cloning nothing. You're cloning nothing here. You're just passing references to everything.
Yeah.
I don't think we can be faster than passing references.
Yeah, exactly.
Right? Unlikely, no. The points parsing is
Passing
the only
references
slow
is
thing.
always the fastest way of acting.
Do you want to try for yourself in Python and see if anything is quicker? If reallocating is quicker, I mean.
Or we can try together if you want, if we have time.
I mean, how long can it take? Let's try.
Brave
Oh,
bird.
no idea. Let's try.
Yeah, okay. So let's
Let
switch
me
screens then.
give you control. There you go. We need to do like a super quick benchmark, right?
Yeah.
Meanwhile, I'm gonna start a prediction. If people want to have fun, they can guess whether this is gonna be faster or not in Python.
You should specify what this is.
Yes, is how do we define that?
Reallocation.
Avoiding reallocation. Is it gonna be faster in Python, right? Because that's what they're trying to do.
Yeah, we are trying to do that. It was time outed. I have to rerun the input one because yes, Colab, if you don't use it for a while, is terminating your instance, so you have to rerun the stuff.
Fair enough.
Not this is the graph, sorry. This one. Okay, so the current solution is running in this time. Let me.
Okay, now
just...
you should be able in the chat to
predict.
to cast your vote.
Channel points.
So we have to create something like you did. So we need the list of points at this point. Will be a list and not a set. Then this will give back a list and not a tuple because we must be able to modify that. And this will give me a list again because we have to modify that. So for every fold, we take the fold at this point, what we did here. Here, for all element in my grid,
I put a vote in the prediction. Oh, a
if
lot of
he's
people.
an X,
Sorry.
Instead of add, what we do that our sublist of 0 new x, because here we are changing the x, will be...
Is that the ice cream music?
Yes, sorry, the ice cream truck is on the road, obviously
Nice.
parking in front of my window. Because...
ask them to cast a vote about Python.
Yeah.
Cool. Instead, if we are folding on y, we change the y. Yeah. And after all of this, we return a set. Here we do the casting to set at the very end. Let's see if we still have the same output, if I did some mistake.
So 86% of the people are thinking that it's not going to be faster. I'm going to give you a spoiler about that. Let's see if they're right or not.
Okay, we have the same output of 2.4 against 2.3. We can run it again to see if there is some noise.
Maybe it's at
2.37, and this one is
the ice cream machine, man.
2.47. It's slightly slower. We could optimize something. Let me think. We can avoid this deconstruction. Could avoid this deconstruction, but I'm not super sure that this is going to speed up something or slow down stuff. Because now we are getting the list. We are taking the folds. We are going through the list and we are changing the elements that are listed. Then we are making a set of everything because we want to be able to count. But doing a set is not even required, to be honest. But 247, let's run again. Even slower. Cool now. Nice.
2.5. So
no, it's slower. In Python, if you don't reallocate but you change in place, it's slower. Nice.
Cool.
I think here we can avoid to return the grid at all, to do the set at all, but I don't think the biggest part of the computation is there. Okay, we have the same output, 244 against 236. No, we are not faster. In Python, it's faster to handle tuples and not list, and work with a set and not a list.
Cool. So it's The opposite of Rust, basically.
Then we can dig Y into the internals. But in any case, it works. It is like this. We run this multiple times, even with noise. This is still saying us that it's better to use set.
Cool.
I wonder
And
if it's
tuples.
because of the garbage collector that doesn't. Maybe Rust it tries to clean up all the time. Maybe
But there is no garbage collector in Rust.
Doesn't. Yeah, no,
in Rust
but
there
Rust.
is no garbage.
But in Rust it will, every time you allocate, it will clean up the previous allocation, right? So maybe it spends time doing allocations because of that, because it also cleans up. I don't know.
No idea. Here I'm using the same hash set. It will not shrink the hash set until a certain point. I mean, it's not shrinking it if it doesn't change consistently the count. No, yeah. I even have in the fastest solution, I have a list here that is taking the set and going back to a list. Here I don't need it because I already have a list. Even in this way, this is slower. But well, in any case, if you want to test your Python performance, do this. Time it. There is also a profiler from the command line that is better, but for getting this idea of numbers, this can be good enough.
Yeah, I like that this one will run it like 1,000 times, right?
Yeah, this is running 1,000 times, and you can run it even more, but I don't know if we have time.
Okay. So, are we good for today, or?
I would say, yeah.
Yeah.
We've messed with this quite a bit, and we've learned something new about Python, not Rust, but hey, it's something new.
But we also learned that modifying an hash set while iterating on top of it is not that easy in Rust.
Yeah, you can use the retain. There are methods that allow you to filter, which sometimes can be useful if you just want to discard items.
Yeah,
but in
but
this case, we just want to iterate and mutate, which is
Here we have to discard and to add in the same loop, because we have to add the reflected point and discard is original, not reflected version. So yeah, it's a little, I don't know if there is a add and retain, add and discard.
Yeah, we could have done it with clear, but we will be reallocating all the time, so it's not allowing us to do what we wanted to do without additional allocations.
Yeah, we need to extract all the points from the set that are outside of the folding boundaries, and with this list add to the same hash set a mirrored version of them. So from what I understand of Rust, you probably need in the hash set type itself some kind of method to do that take ownership of self and does this magic.
Yeah.
Keeping that point references to the point, not point themselves. That with but then you can hash a Okay, this is becoming complicated.
Maybe we could have implemented our own set, but I don't know how easy that is.
But well, you need just a good hashing function, and
because
we know
here the hashing is easy. You can just multiply the two numbers, right? Well, with
you have collision like that.
Yeah, well, you need to add some padding, whatever you want to call it. You need to give more weight to left or right to make sure you don't overlap.
Yeah.
Yeah.
In any case, you can do something. Cool.
But with out of the box stuff, we know, as in without wasting weeks building our own set and stuff, we know what's quicker.
Okay, we have homeworks for the next time. Let's create our own hash set class.
Yeah, everybody build your own sets in your favorite language, even.
But to be honest, in Rust there are crates that implement other kind of hash set, because there is the complaint that the core hash set in Rust is slow. So they have implemented the fastest version, and I think the slow part is the hashing function itself. So
Okay.
Yeah, and in some cases we saw that using B-trees was even faster than using hash sets.
Mm-hmm.
But of course, when you have small cardinality, that's the case. When you have very big cardinality, you'll need to traverse the tree, so it might be slower than just a hash set entry.
Mm-hmm. Yeah, trade-offs. Cool.
Okay, so I think we can call it a day. So I'm gonna do the closing. Thank you everyone for being with us today. As usual, you can find all our stuff on GitHub. Let me see if I can show it. Feel free to send us any pull request or any suggestion. We are trying to learn Rust. As you can see, we struggle to do the most basic things. So if you know any better, please let us know, because we just want to learn. And we'll be streaming next Monday, 6 p.m. GMT, I believe, or whatever is Irish time. And yeah, until then, see you at the next episode. And if you're looking at this on YouTube, we stream on Twitch. If you're looking at this live on Twitch, you can find the recordings on YouTube. So with that being said, see you next time.